Hi guys, welcome to High Score Online Tutorials. Um, if you are new to the channel, make sure you click subscribe button so that whenever we drop videos, you should be able to partake in what we are doing. Today we'll be talking about resolution of three forces at equilibrium. And one good thing about science is the fact that you can approach the problem in so many ways. But in as much as you're able to stick to the rules and the laid down principles of the concept, we will virtually arrive at the answer. Today we'll be looking at two possible ways of dealing with forces, three forces at equilibrium. We're going to be solving the questions with two of the methods, so you should be able to choose which one works better for you. Alright, enjoy the class. Here we have a Y past question of 1999, which says that a 15 kg mass suspended from a ceiling is pulled aside with horizontal force F. Calculate the tension T. In bracket we have G equals 10 meters per second squared, and the options are here. Alright, let's tackle this first of all with the analytical method. So analytical method is aimed at trying to balance the forces. This is a ceiling. There is a cord attached to the ceiling, and there is a load downwards. After which a residual force is being dragged, is being pulled along this way. Now, a simple approach to this is trying to know what happens when forces are at equilibrium. When forces are at equilibrium, it means that the net force is zero. That is, the sum of upward force is equal to the sum of downward force. Likewise, the sum of forces to the left equals sum of forces to the right. Now, since we already have some force downwards this way, and the tension is somewhat upwards, all the best to do is to resolve this system vertically. But before then, all we have here is 15 kg. 15 kg is mass, not force. So for us to make it force, we have to just convert this to weight. How do we do that? Recall that weight is usually equals to mass of the body times G relation to gravity, which is a constant as it is given here. So that this 50 kg mass is, in terms of weight, it is given as W is equals to mass 15 kg times 10. That will give us 150 Newton. That means that the weight due to this mass is 150 Newton. We can now go ahead to resolve. Now, we know that, like I explained earlier, we know that the sum of upward forces is equals to sum of downward forces. Now, because if you watch our last video, I was able to explain to you how you can resolve forces vertically and horizontally. So in that case, the angle made with this, the tension on this string, don't forget the tension is the kind of force you see in a string. For example, when you have a cord this way, if I should drag this way, the amount of force there is what we call tension. The other forces like weight, torsion, and others. So the upward force here is, don't forget, this place will give us 60. That is 90 minus 10 will give us 60. So upward force is given as T sine 60. To make sure you use the force, make sure you use the angle made the horizontal, please. Don't forget. So T multiplied by sine 60, because we're resolving vertically, sine 60 is equals to the downward force, which is 150 Newton. So that T, the tension in the string, is equals to 150 divided by sine 60. Now sine 60 is the same thing as root 3 over 2 over 2. Sorry, root 3 over 2. And if we simplify it, we're going to have, excuse me, it's going to give us 150 root 3 over 2 or 0.860. 150 divided by sine 60. Yes, that gives us equals to 173.2 Newton. That is option B. Alright, we are going to be solving the same question using vector diagram method. Let's see what comes up. Now, in solving forces using vector diagram method, you should be able to master your parallel lines. What you do is, there are three forces here: this, this, and this. We find a way of having a triangle with the forces being the sides of the triangles taken in order, just like it is said in the triangle law of forces. What we do is, we have to draw lines parallel to this, and to this. Let's start with this. This is this way, something like this. Yes, that is it. This is my T. Now, another force is coming downwards, which is, that's a 150 Newton, 150 Newton. Now, how do we make this a triangle? We can make this a triangle. We can make this triangle in two ways. It's either we draw this like this, look at it, or we can actually draw it like this. These two triangles are similar triangles. Any one of them you use will still be correct. So, for this tutorial, let's make use of this. How do you know if you're correct? Look at the force F is perpendicular to the 150 Newton force, and this is it. This is the force F. This is my F. This 150 Newton force. 150. And the tension in the string is at angle 30 to the vertical. Look at it. Vertical. 30. Vertical. So I can now clean up this. We are having triangle this way. So we can now proceed. This is the T, this is the people. We can now proceed. Now look at how the arrow goes. This arrow is downwards. Sorry, this guy is downward. This guy is this way. The tension is this way. You see it now? It was being closed. This, and this. So we can now apply our SOHCAHTOA rule to get T. Now we're looking for T, and we have the adjacent of 30, which is 150, and T is the hypotenuse of the triangle. So we can simply say cos 30 is equals cos. Cos is equals to K, adjacent over hypotenuse. Adjacent is 150 divided by hypotenuse T, so that T is equals to 150 over cos 30. That will automatically give us 150 divided by 0.8660 automatically gives us 173.2 3.280. You see, what the thing we got here. There's no magic to doing it. You just have to apply the rules. Now let's assume we use the other triangle this side. That was one like this. Here could have been 30. Vertical opposite angles. 150, and this guy. See, we got the same answer. So that would have been tan 30 equals to adjacent 150 by hypotenuse. See here. That's no. Sorry, cos 30. Sorry, cos 30 and equals to 150 over t. So that's t equals 150 over cos 30 as before. Yes. Alright, here we have another problem of three forces in equilibrium. So this is something like it can be a paper or an object rectangular in nature with a string, two strings attached to it onto a platform or a ceiling. Another force, so the weight of the material now comes down like this, that is 20 newton. We have to find the tension in the string, which is T. Alright, so let's see here. So we're starting with the first method, analytical. To do that, we still have to apply the same principle of sum of upward force equals sum of downward force. Upward forces here are T and this T. The component of this T that is acting upwards is given as, because this is 30, this is 30. Yes. 30, 30. Because they are alternate angles. Alternate angles are equal if this is parallel to the top. So that the first force here is T sine 30 plus same second one this place. T sine 30 T sine 30, yeah. So plus T sine 30 equals downward force 20. Sine 30 is something as 0.5. That is 0.5 T plus 0.5 T equals 20. This will give us T equals 20 newton. This obviously sounds too simple. Alright, this is the first method. Now let's apply the second method, which is using vector diagram. Sorry, permit me to bring this just this side so we can. I think we can actually do this here, perhaps. Or let's just bring everything so that's clear enough. Alright. So we have three forces as usual. Draw a parallel line this way. Parallel line. This is, let's call this T1, T2, sorry. This is T2. Another one comes like this. Yeah. Another one comes like this. Just sorry. No, let's bring this up. Let's bring this up. This one comes down like this. Come down like this. Don't forget that this is 60. Sorry. This is 60 degrees. This is 60 degrees. This is T2. This is T1. Like this, like this, like this. Yes. Yes. This, and this. Now, how do we now get the angles? Don't forget that this is T2. This is 20 Newton. So 20 Newton is this is. Don't forget that the angle between this, which is prior to this, and this is 60. So here it automatically becomes 60 degrees. This place to 60 degrees. And the angle between this force and this force is 120. Automatically becomes 120. T1. Don't forget that T1 is equals to T2 equals to T. Right. So we can now apply sine rule. In doing that, this 20 over sine 120 equals T, and what we use is T1 or T over sine 60. Sine 120 is 0.8660 equals T over 0.8660. So that's T 0.866 T equals 20 times 0.866 divided through by 0.866. 0.866. We have T as equals to 20 Newton as before. Alright, thanks for watching. In our next video, I'm going to show us what to do when there is no angles given. Like in this question, there is at least there's an angle given here, 30-30. In some questions, you may not see angles. So in my next video, I'm going to show you how to treat questions without angles. What I mean is something like this. Question like this. Yeah, some stuff like this. Stuff like this. Yeah. Of course, we know here is 90, but how do we get this place and this place? Watch out for next video. I'm going to do a video on it so you can learn more. Thanks for watching. Before you leave, make sure you subscribe to our channel so that whenever we drop questions and your solutions, you should be able to follow up. For our physical classes, we have physical classes in Songwater for those who can make it to our classes. Morning classes and evening classes are available. God bless you.